Hello, this is section 2.4, question number 19. We are asked to prove the statement using the epsilon delta definition of a limit. In this specific case, we are asked to prove that the limit as x approaches 1 of 2 plus 4x divided by 3 equals 2. When attempting these problems, I like to do two parts. Part 1 is the pre-work. And in part 1, we need to do two things. Number 1, find a number, delta, such that if x minus a, its absolute value, is less than delta, but bigger than 0, then f of x minus L, its absolute value, is less than some epsilon. This is the definition of a limit. What we want to do is start with the epsilon part and work to the delta part. So f of x minus L is less than epsilon. That's the part we're going to start with. F of x minus L equals 2 plus 4x over 3 minus 2. That's less than epsilon. Now what I want to do is work this down until I algebraically find x minus a absolute value. Then I can compare the x minus a absolute value to an epsilon. So what I did, f of x minus L absolute value, plugged in f of x minus L. Now let's simplify. Found a common denominator for the negative 2. Put the fractions together. Simplified. Factored out of 4 over 3. Since 4 over 3 is always positive, I wrote that as an absolute value. 4 over 3 absolute value times the absolute value of x minus 1. That's still less than epsilon. Since 4 over 3 is always positive, then we can just write that as 4 over 3 times the absolute value of x minus 1, and that's less than epsilon. I multiply both sides by 3 over 4, and that simplifies to x minus 1 less than epsilon times 3 over 4. Now remember, we have been working to get to the delta part, which is x minus 1, absolute value of. So, x minus 1, x minus a, its absolute value has to be between 0 and delta. And we're going to compare that to this situation of x minus 1 is less than epsilon times 3 over 4. So I'm going to try my delta to equal 3 over 4 times epsilon. All of that work was just the work to figure out what I should try for my delta. Now the actual proof. And what we're doing in our proof is showing that our choice for delta actually works. When we make a delta epsilon proof, we always start the same way. Proof. Let epsilon be bigger than 0. With, then we write our choice for delta. In this case, delta equals 3 over 4 times epsilon. If, then we write the x minus a part, absolute value, between 0 and delta. So in this case, if the absolute value of x minus 1 is between 0 and delta, then we must show that f of x minus L is less than epsilon. Consider. Start with f of x minus L. Remember, we're saying from the if statement that x minus 1 is less than delta. That's what we're assuming to be true. Then we have to prove that this part is true. So we start with a statement that we can just say is true, f of x minus L. But we haven't proved it's less than epsilon. So we can't write epsilon anywhere until we're finished, because that hasn't been proved. So f of x minus L, absolute value. We plug in f of x, 2 plus 4x over 3. We plug in L, which is 2. Find a common denominator, combine the fractions, simplify. Pull out the 4 over 3. 4 over 3 is always positive, so I can write that as an absolute value of 4 over 3 times absolute value of x minus 1 equals. 4 over 3 is always positive, so I write it as 4 over 3 without the absolute value sign. Still times the absolute value of x minus 1. That is less than 4 over 3 times delta. Why is that true? Well, remember, we said that x minus 1 absolute value has to be less than delta. 4 over 3 times x minus 1 absolute value is less than 4 over 3 is the same as 4 over 3. That part's equal. X minus 1 is less than delta. So therefore, 4 over 3 times absolute value of x minus 1 must be less than 4 over 3 times delta. That's equal to, well, what's delta? Plug in delta with the 4 over 3, and we just get epsilon. So we've done what we need to do. We must show that the absolute value of f of x minus L is less than epsilon. The absolute value of f of x minus L equal, less than, equal, epsilon. Therefore, by the precise definition of a limit, the limit as x approaches 1 of 2 plus 4x over 3 equals 2.